I'm Kalyn Diederich. I'm a fourth-year PhD candidate at University of California, Davis. Originally from Northern Colorado, I got my Bachelor's of Science in Soil and Crop Sciences at Colorado State University. From there, I transitioned to UW-Madison, where I got my Master's of Science in Agroecology and Soil Science. Now, here at UC Davis, I'm in the Soils and Biogeochemistry graduate group. My dissertation research largely focuses on a novel perennial grain crop known as Kernza. Kernza is an agronomic crop that produces a wheat-like grain that, while it does produce less grain than annual wheat, we can use this grain in cereals and beers and breads. And unlike annual wheat, we don't have to till and replant Kernza each year because it's a perennial. If we look over here in the photo, on the left is Kernza growing and on the right is annual wheat. And we can clearly see that the rooting structure and the rooting depth of Kernza is much different between the perennial and the annual grain. And I want to keep that in mind as I show you a little bit of data moving forward. Now, prior to 2017, most of the research on Kernza has taken place in the Midwest or Northeast USA. So my advisors and I started the first long-term field evaluation of Kernza in the state of California, where we compare tilled wheat, no-till wheat, and Kernza along gradients of nitrogen fertilization and irrigation, as shown in this aerial photo. When I say compare, I mean comparing above ground components like biomass yield and grain yield, but below ground components as well, such as soil health. A really common soil health indicator that we looked at in our study is mineralizable soil carbon. Mineralizable soil carbon is thought to be a pool of carbon that is easily accessible and broken down by microbes. And so we can think of it reflecting overall microbial activity in the soil. And what we found is that across time and across depth, that Kernza had generally about 40% more mineralizable soil carbon than annual wheat. But let's look at a little bit more specifics. If we look at this data slide, we see that on the right, at the very top, annual wheat is the gold data points and perennial wheatgrass or Kernza is the blue. We sampled at 3 different time points, 2018, 19, and 20, at 3 different depths, 15, 30, and 60 centimeters going down the y-axis. And then we have mineralizable soil carbon along the x-axis, increasing from left to right in each panel. And what we see is that the blue data points, again, Kernza, generally were higher than the annual wheat data points in mineralizable carbon. However, it's really at the 30 centimeters and especially at the 60 centimeters that we see that Kernza consistently has more mineralizable soil carbon than annual wheat, which makes sense when we look back at that photo and we see that those roots are going deep into the soil profile and likely releasing carbon. With that being said, I would like to thank you for your time. Please check out my poster if you'd like to learn more. And thank you, ARCS, for your support.